My name is Lena Reinke. I work as a business development manager for Panacol, taking care of all topics if it comes to organic, photovoltaic or perovskite-based ones in combination with adhesive solutions. Panacol is a quite small company, having 100 people working for Panacol. But we do have some additional subsidiaries all around the world, China, USA, also in France and in Korea. And we are having our R&D at Panacol, an application engineering department, and the whole production line is also in our new headquarter here in Steinbach, which is next to Frankfurt City. Why are we taking care of those solar topics? I think there's a big need for sustainable energy solutions, and the typical crystalline silicon solutions, we are all familiar with that, but as there is a really big demand for sustainable energy solutions, OPVs and perovskite-based solutions came up in the past years. And what we see is that, for example, in case of road-to-road processing, adhesives, especially liquid adhesives, can be a solution here. And Panacol can bring the adhesives to potential customers, and our mother company, Höhnle, who is doing the curing equipment, can bring UV lamps. So this can be a quite fruitful cooperation here. We see several bonding tasks within this schematic picture of an OPV encapsulation step. And first I want to take a deeper look in the lamination itself. Here we have our product line, which is called MicroLED. These are all UV curing adhesives or dual curing ones. Sometimes you need a second heat curing step. And this is all collected under the MicroLED group at our company. The curing itself is done by Höhnle lamps. And a typical Höhnle UV lamp can have a certain UV range. But for our topics, we go with distinct wavelengths of 365, 395, or 405 nanometers. And on the right side, you can see a transmission curve of the transmission curve of a 150 micrometer PET foil. And for 405 nanometers, you can see that 80% of the light can pass the foil and therefore cure the adhesive, while, for example, for 365 or everything which is lower than 400, the transmission will be lower and the curing won't be that sufficient. So we always recommend 405 nanometer curing here if it comes to PET-based substrates. Now the chemistry. It's just an easy example, but we do have initiators in our epoxy systems, for example, because this is one of the adhesive groups that we are taking care of. You can have, for example, this iodonium component here, which is then irradiated by light. And therefore, you have the formation of a superacid, which will then start the polymerization reaction. We will end up with a epoxy-based polymer. On the other hand, there are radical polymerization mechanisms where you also have specific initiators that are excited by UV light, and then also forming a polymer which is made out of acrylics. In the end, it doesn't matter. Those polymers need to address certain requirements. And this is from our knowledge, most of the time a good barrier property, as OPVs and perovskites really don't like water ingress, and also oxygen is not always good to have in here, so we need good